What's up, YouTube? This video is for Class CSCE 2100, Discussion 13, and I'm going to be explaining 5 concepts from the review exercises from Lecture 27. So first up, we have set cardinality. Cardinality refers to the number of objects in a set. You can see set A right here, and we have 5 objects in the set. The first object is a tuple with its own cardinality of 3, but in this set, the tuple itself only counts as 1 object. The second object is Mary, third is 45, fourth is CSCE, and fifth we have 2 symbols for the empty set. So it looks like there's 6 objects in the set, but the last 2 are the same since they both represent the empty set. Therefore, the cardinality of set A is 5. Secondly, we're looking at partitions, and a partition is any combination of objects in a set. So the examples you see here are 1, 2. This exists within the set, so it's a valid partition, as is the case for 5, 4, 8, and 6. Those are all partitions of this set. So next, the power set basically refers to the number of possible partitions within a set, denoted by the equation 2 to the power of n, where n is the number of objects in a set. So in this example, set S has 7 objects, so the power set is equal to 2 to the 7th, which is 128. All right, fourth, we have partial versus total functions. So a function is considered total when all its conditions are satisfied. For example, with function a, it asserts that y is equal to 3x and that both x and y belong to the set of real numbers. This is true for the function as any real number you substitute for x will always result in a real number for y, and vice versa. However, in function b, x equals -1 would result in 0 in the denominator, and anything divided by 0 is undefined, so y would become a non-real number. Since the condition for y being a real number cannot be met, b would be considered a partial function. Okay, last up, we have relation and function properties based on this graph G right here. And you can see the set G, which defines the relations in the graph. So now we'll run through each relation property for graph G. So first is G symmetric. For G to be symmetric, if A relates to B, then B must relate back to A. So looking through this list right here, we have A goes to B, and B goes to A goes to C goes to A, so on and so forth. So it appears that graph G is symmetric. Second is G reflexive. The answer is yes, because each node relates to itself. The domain is A, B, and C. A relates to A, B relates to B, C relates to C. So graph G is reflexive. Third is G transitive. For G to be transitive, if A relates to B and B relates to C, then A has to relate to C. So basically, B links A to C. So for these examples, we have A to B, B to A to A, that's correct, A to B, B to C, A to C, that's right, A to B, B to B, A to B. And this trend continues for the rest of the pairs, so graph G is transitive. So because graph G has these 3 properties, it's referred to as an equivalence relation. And those are the 5 concepts. Thank you for watching.